Welcome to Electronics Techie. So in this video we are going to discuss about the up counter. So how we are going to design up counter in synchronous. So there is a synchronous counter and asynchronous counter. So whereas coming to the asynchronous counter, the output of the first flip flop is going to be input to the second flip flop. But while in coming to the synchronous up counter, so every flip flop containing the same clock. Here we can observe the single clock is going to apply for every flip flop. So it is the synchronous up counter. So in up counter, what you are going to do? So you are counting from 0 to 15 in up counter, means 0, 1, 2, 3, 4, 5, 6. So coming to down counters, it will be count like that 15, 14, 13, 12 like that. So in up counter, we are going to count 0 to 15. Just remember that. So here we are using enable pin or reset pin. So what is the difference means? If the enable pin is equal to 1, so then your flip flops is going to be activated. If your reset pin is 1, so your flip flop is going to be stop. So in enable pin is equal to 0, so then your flip flop is going to be stop. Here is in reset, if the reset is equal to 0, then your flip flop is going to be active. Means these two pins are going to be a reverse condition. You can use any enable pin or reset pin according to your design. So and next one coming to the outputs. So how you are going to collect? So for single flip flop we are getting single bit. For requiring 4 bit means we are going to count 0 to 15 values. We require 4 bits. 4 bit means 4 flip flops. So number of bits we are going to take, that number of flip flops we are going to require. So 2 power 4 is equal to 16. That means 0 to 15 we are going to count here. So this will be the output of Q of 0 and Q of 1. I can name it as Q of 2 and whereas coming to Q of 3. So how you are getting these Q values means at that particular flip flop what is the output, you have simply take that particular values. So what are the inputs of this particular T flip flop? So we are simply give the T of 0 and the output of the first flip flop and input of the first flip flop is going to be AND gate and it will give to the second flip flop. So like that AND operations of the previous input and output is going to be input to the second means next flip flop. So you can done like this. So it is the block diagram. By using this we are going to design the design code of this up counter in Verilog. So see here, by using these truth table you can simply understand this diagram also. So when you are going to get by using T of 0, so here see, when you are getting Q of 0, whenever you are giving the input T of 0, this particular input, you are getting this particular output. For getting Q of 1, you are giving this particular T of 1, then only you are getting this particular output. So for that purpose, so for T of 1 you are getting this Q of 1, for T of 2 you are getting this particular output, for T of 3 you are getting particular this output. So see, whenever the T of 1, T of 0 is equal to 1, then only your Q value is going to be toggle for every clock pulse. Sure, that's why you are make every time your T of 1, T of 0 is equal to 1. So every time you are make T of 0 is equal to 1. So you can understand this particular input, what you are going to give this particular T of 0, you can understand. Now what you are giving this particular T of 1. See here we can give T of 0 AND operated with Q of 0. So see here, T of 0 AND operated with Q of 0. So what is the T of 0? 1. So 1 AND operated with Q of 0 is nothing but Q of 0. So for this T of 1 we are going to give the Q of 0. So what it means? So if your Q of 0 is equal to 0, then your output will be the same. Whenever your Q of value is equal to 1. So see here, your Q of value is equal to 1 means your Q of 0 is equal to 1 here. So then it is going to be toggle. So how it is going to be toggle from 0 to 1? Here there is a toggle here. So again if it is 0, so then there is no toggle here. See this particular thing. So if there is 0, there is no toggle in this between 2. So if there is 1, there is a toggle between this 0, 1. So again this 0, there is no toggle between these two inputs. So next you can see there is a 1. So that's why you have to observe the toggle here. So here you can observe there is a 1, 0. There is a toggle. So whenever the Q of 0 is going to be 1, see here if the Q of 1 is equal to 0 going to be 1, then that particular step you can observe the toggle. So 0, 1. So if there is 0, so there is no toggle. There is a only 1, 1. If there you can observe again, it can be use any line. So here there is a 1. So at this particular line you observe the toggle. So you can observe. If there is 0 means there is no toggle. So like that we are going to consider T of 1. So like that we are giving the input to the second flip flop. So how we are going to give the third flip flop? Here we can observe T of 1 AND operated with Q of 1. Sorry. So here what is the input here? T of 1 AND operated with Q of 1. So what is the T of 1? So T of 1 is nothing but Q of 0. So Q of 0 is AND operated with Q of 1. So for this particular T of 2, you are going to give the Q of 0 AND operated with Q of 1. What it means? Whenever the Q of 0 and Q of 1 both are 1, then your output is going to be toggle. Means why I am saying toggle means your T value is going to be 1. So whenever your T value is going to be 1, then only toggle will be going to happen. So see here, whenever these two conditions are going to be true, then you can say that it will be fine. So once 1 minute, I will erase these all things. Then you can understand properly again. So here I am considering what are the inputs we are giving that particular to getting this output for the up counter. So just listen carefully. So see here, whenever the Q of 0 and Q of 1, then only we are going to be toggle. So see here the both are false. That means there is no toggle is happen at this particular step. There is no there is a 0, there is a false condition, there is a true. Means 0 means false and 1 means true. So means 0 and operated with 1 is nothing but false, 0 only. So there is no toggle. So then also there is 0 0 only. So here you can observe there is also no toggle. Here you can observe. So here there is a 1 1. So both conditions are true. Then there is a toggle, means there is a opposite sign we are going to get. So here the 0 will be converted to 1. So like that, for whenever the two inputs means two outputs Q of 0 and Q of 1 both are ones, then only your output of second flip flop is going to be toggle, means third flip flop is going to be toggle. Same as for the Q of 3 also. Whenever both all the inputs, all the outputs, so whatever the first flip flop, second flip flop, third flip flop, all outputs are going to be 1. So see here in this particular line the all flip flops are going to be same. Then only the toggle will be going to happen. Here you can see there is a toggle. So 0 is converted into 1. So like that we are going to design. So I think if you are understand this table, then it is very easy to write this code. So first we have to write module followed by module name. So T underscore flip flop. So I have to write two modules here. So why I write means, so here what you are using T flip flop. So for writing T flip flop is one case and connecting all these flip flops is another case. So first we have to write code for T flip flop. Then we are going to connect these all T flip flops and make as a up counter is another module. So first I have to write the T module or T flip flop module. So that's why I make it as T underscore flip flop. So T underscore FF. So input, what are the inputs we are going to give? Clock. If you take reset the enable pin, it is up to your choice. So here I take reset pin. So for T flip flop there is input T and output Q. So why I make range means whenever you are going to use always block, so you have to make it as a range data type. So always at the rate pause edge of clock or pause edge of reset, means whenever the clock means pause to edge of clock, then your flip flop is going to be done only activate at this particular positive edge of clock itself. So if you are reset, so if reset value is equal to 1, so if your reset value is equal to 1, what will going to happen? So your all flip flops is going to means whatever the flip flop output is going to be 0. So that's why you simply make it as a 0. So else if your reset is not equal to 1, so then what will happen if your reset equal to 0? So then what will going to happen means, so it will be going to be done this process. So what again it will check the T value. If the T value is equal to 1, it is going to be toggle. So what is the output of Q is going to be toggle and it will pass to the Q. So else, otherwise if your T value is equal to 0, again same Q value is going to be passed. If it is 1 only, then it is going to be toggle. You all know about the T flip flop. So this is about the T flip flop code. So coming to the up counter code. So module it is up counter, that's why I make it as up counter. It is a 4-bit up counter, that's why I make it as a 4 counter 4-bit, means 4-bit up counter means up underscore counter underscore 4-bit. You can take any name what you like, but there is some rules. So don't start with any number, don't give any spaces between this module name. So you have to follow that and make it as a good name for what is suitable and which is follow to rules and what is the understandable thing when you are watch in previous time, means in future also. So what are the input for the up counter? So again you can see clock, reset and the 4 outputs. So 4 outputs means you can say here in code I take it as a reset, clock and 4 outputs. So how you are writing 4 output in vector form? So how you can going to write means 3 down to 0. If you write like this means Q of 0, Q of 2, Q of 1, it means same. So we are going to get the 4 bits. So this we are going to write like this. So here we can write wire, means there is no always block. You can write wire. If you don't write also it naturally take a wire itself, so no need to mention it particularly a wire. So it up to your choice. Why I write wire means I have to make the difference here. So when you are going to use reg, so if you don't mention anything wire or reg, it defaultly take wire itself, so no need to worry about the wire data type. So but when you are going to represent the reg, you must and should write the reg data type. So wire. So why I am taking these values means here you can see in the design code I have to take some inputs. Here you have to connect the inputs between the T flip-flops. So those can be as the intermediate wires. So no need of inputs for the up counter. So for that inside wires which is necessary, which is unnecessary to collect the data giving information, so that will take as a wire. So it will be by connecting in the inter parts means interior parts. So no need to take any output from those parts. So that's why I make it as a wire. So SN. So I already said that how we are going to give the T of 0 values, T of 1 and T of 2 and T of 3. So for T of 0, what I say, every time we make it as a 1. So that's why I simply write T of 0 is equal to 1. So why I write 1 tick B 1 means, so here the 1 represent how many bits we are going to take here. So here 1 means only 1 bit I take, so 1 tick. So B is nothing but it will be binary or decimal, octal or hexadecimal. B means binary, D means decimal, H means hexadecimal, O means octal. So here B means binary. So that's why you can represent like 1 tick B1. So assign T1 equal to Q of 0. So I already said that. So how we are getting T of 1? So by giving T of 0 and operated with Q of 0. T of 0 is nothing but 1. So 1 and operated with Q of 0 is nothing but Q of 0. So that's why simply give the code Q of 0. So for T of 2, you are giving, see here. So what is the Q of 0? We are going to give and operated with Q of 1, it will be going to be the T of 2. So that's why simply write T of 2. For T of 3, we are giving all the AND operations to the T of 3. Like that we are going to assign this T0, T1, T2, T3. These are the input for the T flip-flops of 4 flip-flops of up counter. So now we are going to connect these T flip-flops. Then only you are getting the up counter design. So here now we are separately design the T flip-flops. Now we are going to connect all these things by using T flip-flops. So how we are going to connect means instantiation. So how we are going to instantiate? So first we have to write module name. So T underscore, what you are going to instantiate T module. So T underscore FF followed by instance name. You can take any name, your name also, no problem itself. So if you take in professional manner, you can take anything, FF not. So for clock, here what is the connection is the port connection by name. So this clock, what is the clock here? Up counter clock is going to be connected to this particular clock. What is the reset is going to be connected to this reset. So inside the brackets you have to write the up counter values. So what is the main module, is the instance module. So how to connect like this. So again this T0 value is going to connect to the T flip-flop of the T value. So like that we are going to connect this port connections by name. I already said that how you are going to connect port by name and port by order. So if you don't know, once watch those video, it will be more understandable while you are going to connect. So again for T flip-flop 2 we are going to connect like this. T of 1 is going to be, so you see here, so T will be going to connect to T of 1, here the T will be going to connect to the T of 2 and T will be going to connect to the T of 3. Coming to the clock, so clock is connected to clock. Here this means this clock is the T flip-flop clock. So this clock is the up counter clock. So we have to connect this up counter clock with T flip-flop clock. So that's why I have to make these port connections. So this Q is connected to count of 0 or nothing but here I can take Q of 0. So again this Q is going to connect to the Q of 1. So like that here we can see Q is connected to Q of 0, here Q is connected to Q of 1, Q is connected to Q of 2, like that we are going to connect. So after connecting these all things, so now we are making the up counter, so followed by end module. It will be the end of the connections in design code. So I think if there is any doubts in any unclarification, there is no clarification in anything, you can comment on it. I make separate and small video in understandable way by different examples or different design and another type of design like that. So here is the test bench. So module followed by, so time scale means it will be said that how much simulation time it take to, means for every waveform means here you can see nanoseconds, 20 nanoseconds, 40 nanoseconds. So it will be pico nanoseconds. That's why it make it as this line means. So module followed by module name. So you can take any module name. This is the test bench. So that's why I make it as a TB underscore up underscore counter underscore 4-bit. So what are the inputs we are taking, that will be make it as a reg data type. What are the outputs, we make it as a wire data type. So you can make these are the wire also, but why you make reg means, so whenever you are going to use the initial or always block, so then we have to make those variables. What are the variables we are going to use in these blocks, that make it as a range data type. So that's why we make it like this. Swap underscore counter underscore 4-bit. So followed by instance name. So this is the port connection by name, clock, reset and Q. So this clock, reset, Q are going to connect to the design code of this clock, reset and Q. So next initial begin. So what you are going to do means, so first you have to give clock equal to 0. So clock equal to 0 forever. Always block or forever both are same. So the main difference is like we are going to use begin and end here. So in always block no need to use any begin and end here. So forever means for every 5 nanoseconds of time your clock is going to be toggle. So if it is 0, then after 5 nanoseconds it's going to be 1 0 1 0 1, like that it is going to be toggle like this. So initial begin, if your reset value is equal to 1, so now your reset value is equal to going to be 1, what will happen? So all the values are going to be dead. So your flip-flop is going to be make it as a 0. So whenever your reset value is equal to 0, then only your flip-flop is going to be activate. 0, 1, 2, 3, 4, it is going to be count the values. If your reset is equal to 1, it make it as 0, 0, 0. There is no counting because your flip-flop is going to be off. So after 200 nanoseconds of delay, your simulation is going to be stop. So if you give finish keyword, it make it as a stop. So end, what is the begin here written, so it will be end and followed by end module. So this is our simulation, we can observe. So this is the clock, for every 5 nanosecond it is going to be toggle like this. So if your reset is equal to 0, I said that your what is the values is going to be 0. So for next step, it is going to see here, this is the passage of clock. At this point 0, and this passage of clock, it is going to for every passage of clock. Why only passage of clock? See here in design code, you said that for every passage of clock. That's why you can say that for every passage of clock, your output is going to be toggle. So 5, 6, 7, 8, 9, 10. So here A means hexadecimal. In decimal, you can set that 10, 11, 12, 13. 14, 15, again 0, 1, 2. Like that it is going to 0 to 15, again 1 to 0 to 15. So like that we is going to count the values. So this is our what you can say that schematic diagram. So this is our schematic diagram, we can observe here. So see, you have to give clock for all the flip-flops for the same. Here the clock is going to pass for all the flip-flops, and the reset pin also is going to be same for all the flip-flops. So for T it is going to be 1. VCC is nothing but 1. So you can see T flip-flop. So for second T flip-flop, what will going to happen? So it will be end operated with the both the ones, and it is going to be applied to the second flip-flop. So for third flip-flop, what is the output, and these two are going to be activated for this T flip-flop. So like that it is going to be, what is the code we have written here. Simply it make it as a this diagram. So I think it's fine. If you have any doubts, you can comment on it. And thanks for watching, and thanks for keep supporting me, and thank you very much, and then bye.